Hi, how are you all doing? I've got a question for you. What is the thing that you think of first when starting a new project? Is it this new fancy framework you've been dying to use for quite a while now? Or are there new colleagues in your company with whom you wish to work with? Well, one of the things that I like when starting a new project is having a clear overview of all the data flows within a project. Having a clear overview of what service talks to what other service and how they communicate. Maybe a visual interface is needed, or a well thought out URL structure for a sitemap. Maybe you have to implement some captivating interactive functionalities. How does the user interface relate to the data management side of the project? Should the content be available through Markdown files? Or do you have a content management system that provides a GraphQL API? Perhaps a RESTful API is at your disposal for this project. There is a plethora of ways of sending and receiving data, and there are multiple environment constraints that will influence those possibilities. Today, I'll be sharing with you one of the biggest revelations in my day-to-day workflow, and something that I am convinced of that every developer in a mid-sized to large to enterprise-grade team should have in their mental backpack. And that's called the Open Api Specification. You ready for this? Let's go! My name is Martin. I am a senior front-end developer at Isaac, which is now part of the Interactor Group, and we are based in the south of the Netherlands in the lovely city of Eindhoven. At Isaac, we specialize in providing integration, identity, access management services for large businesses in the e-finance and e-commerce landscape. We're not shy of taking on large projects. That's why one of our slogans still is, we love .complexity. Next to sprinkling some front-end magic on those big projects, I'm also an open source advocate. This means I try to create awareness for open source and the importance of open source software in our current day society. I am also an advocate for the Open API specification within Isaac. This means I try to help my colleagues integrate the Open API specification into their projects because the benefits are clear. Let me show you. Let's say we have a classical web application architecture where our backend is tightly coupled with our front end. This means backend languages and front-end languages will maybe be interwoven with each other. Users will directly talk to that one monolith of a service. We at Isaac believe that every developer should be able to specialize themselves in their domain of expertise. In this example, this means separating our backend from our frontend and creating a headless architecture. Our frontend is a separate view layer from our business logic, which lies in the backend. Our users will talk to the frontend. This gives both projects the benefit on focusing on their domain of expertise. But what if we have more clients that need data from our backend? Maybe native mobile apps. Maybe you want to expose your services to other parties in the cloud. Now that we've separated our teams into their own fields of expertise, a backend, a mobile client, a progressive web app maybe, how does each consumer know how to communicate with the provider? Is there a documentation page? Is there a Slack channel? Do we send information back and forth through email? No, we shall not. We shall create an Open API document, which will then be shared throughout the entire project. This Open API document shall be treated as the contract in how to communicate with the provider, which data the provider will send back if you request it, and which data the provider shall take in when you communicate with it. The Open API specification, or the specification formerly known as Swagger, defines a standard language agnostic interface for RESTful APIs. Its purpose is to be easy understandable for both machines and computers, and tries to be that with a minimal amount of implementation logic. Basically, it's a YAML or JSON file formatted in a predefined way, which describes the way of communicating with the provider. Which data goes in, which data comes out. Let me give you a quick example of an OpenAPI document. First of all, let's specify which version of the OpenAPI spec we're using. We're currently at version 3.1.0. Then we can specify some general info about the API, maybe some contact details if things break. We can then specify some servers. Maybe you have multiple environments you're exposing, a test, staging, production. You can state the base URLs of each environment here. Then we can state our paths, so our URLs and our operations. We'll look into that a little bit further down the road. Then we can state our components. So OpenAPI is about reusability. We can reuse data models throughout the entire OpenAPI document, so we can stay dry. We can describe security mechanisms like OAuth or OpenID Connect. Maybe there are some long-lived tokens that are necessary to talk to your API. You can state how and which security scheme you'd like to use for authorization. Then we can add some tags, and we can also add some links to external documentation if the OpenAPI document does not suffice. And new for this year is the addition of webhooks. So normally your backend, your API is the provider for that data, or maybe you want to have some webhooks where your consumers become the providers and start the initial request back to your backend. This is a place similar to paths where you can describe those operations. So let's look into the two big parts of an OpenAPI document, paths and components. A path, or in your paths, you state your operations. This means your URL, your methods, your operations. In your operations, you can describe your parameters, where your parameters live, maybe in headers or maybe in the path itself. Maybe there's a request body, and you can also state your responses. You can state which status codes are returned, maybe a default status. And to each status, you can describe the content that's returned. In this case, it's a JSON that will be returned, but you can also define XML or plain text. In this example, the response content is a reference to a component. Like I said a few moments ago, components are a reusable part of an OpenAPI document. In components, we can describe our schemas or maybe responses that should be reused throughout the document. We can describe request bodies, maybe much used headers, and so forth and so forth. Components can be made of objects, arrays, of strings, of enumerators, you name it, and pretty much anything that can be sent back from an API. You can then reuse those components in other components to have a much more dry OpenAPI document. So now we know what an OpenAPI document describes. How can we use it in our project? Well, there are two major approaches. The first approach is where we have an existing API that's already up in the cloud and that's already been built, and that provides us with an OpenAPI document written manually or maybe generated. Because if you're using a more batteries included framework, you might have the possibility of generating an OpenAPI document. For instance, if you're using Spring Boot in Java, you might want to take a look at Spring Doc OpenAPI. This takes your interfaces and your services which you expose and creates an OpenAPI document from it. Same for the .NET ecosystem, where you can take a look at Swashbuckle or NSWAG. If you're using Node.js or a more MVC-like framework for Node.js, like Next.js, you could take a look at their Swagger module, which generates an OpenAPI document from the controllers and the DTOs you create. So this way we have a document we can easily share with our consumers and they can build an API on. The second approach is where we take the OpenAPI document as starting point for our project. This way, all consumers can contribute to the specification and make sure their requirements are met. This way, our OpenAPI document becomes the single source of truth for our project. Providers can contribute, consumers can contribute to the design of the API, but also other stakeholders, like maybe a product owner that has an idea about the future implementations for the project. So now our OpenAPI document has become the center of our project. And that is cool because it's built on a specification, and on specifications, tooling can be built. And we can harness the power of that tooling in our project. For instance, the most commonly known example in the OpenAPI ecosystem is generating our documentation. We have a technical file that we want to visually enhance for maybe other stakeholders in our project that are not that technical or do not understand YAML or JSON. Some OpenAPI documentation generators are Swagger UI and Redoc. A second powerful tool we can harness the power of is SDK generation. We can map the description of the OpenAPI document to programming languages and create methods, interfaces, types, an entire SDK that consumers and providers can integrate into their project. For instance, maybe your mobile clients are built on Kotlin on the one hand or Swift on the other hand. Your web applications might use TypeScript or plain old JavaScript. Maybe you want to provide third-party consumers with a Node.js SDK or Go or C#. The list goes on and on. The possibilities are endless here. We can also generate the communication layer of our server, the interfaces to which your services should talk to. And we can go even one step further and we can generate other types of services that our clients can talk to. For instance, a GraphQL server. Both GraphQL and OpenAPI are built on a concept of a schema, which describes the entire communication layer. So if you find the right tool for it, you can map your OpenAPI document to a GraphQL schema. There are literally hundreds of SDK generators out there. If you want to use one, I suggest you first look at openapi.tools, which is a site which provides all kinds of tools for OpenAPI documents. OpenAPIgenerator.tech is a well-known one. It's Java-based and outputs to multiple programming languages. My favorite client generator at this moment is OpenAPI TypeScript Cogen. A third tool that I really like harnessing the power of is a automated mocking server, something like Prism that is made by the people at Stoplight. It takes your OpenAPI document and transforms it into a fully fledged API server with fake data, with mocked data, and with validation. Let's take this example here. I have this path that I defined. It says, get me a list of pets. If status is successful, then give me back an array of this object, of this ID, and with this name. And by starting a simple command, which I'll show you in a few moments in the demo, I'll get back a perfectly formatted JSON as described by the OpenAPI document with fake data in it, which then I can use in my front-end project or my consumer project. This allows nearly full independence from your actual provider. The last thing I like to show you is when you use your OpenAPI document as your single source of truth and build all kinds of automation around it. For instance, when a new OpenAPI document version is released, you can generate your SDKs. You can compile new documentation and upload it to the documentation website. Your consumers can pull the changes back into their project and start working with a new mocking server to see if their application still holds up through the new API changes. Automation is key in every modern day workflow, and that is also the case in a workflow where OpenAPI is involved. All right, let me give you a quick demo how the OpenAPI specification can be integrated in your workflow. I've created this demo package. You can find the links I will put in the description and on my website. I created a monorepo style of a project where I have a few packages that are dependent of each other and which I've separated into their own domains. First of all, we have our OpenAPI package where our OpenAPI document lives and where we have installed a linter to check the documentation's format. If everything's checks and validates the OpenAPI document. And with a simple click on the button, we can start our linting process and it will check if there are any errors in that OpenAPI document. Nope, no errors, everything okay, no result with a severity of error or higher found. Cool, our OpenAPI document is as we like it. Then I've created a package where our mocking server lives, and that's a pretty easy thing. It's the Prism CLI. Prism gets its OpenAPI document from a folder back, and then in the OpenAPI pet store YAML, we can start this, and then it will start a mocking server in our terminal. Then we have the SDK, and the SDK uses the OpenAPI TypeScript cogen to generate a TypeScript-based SDK from that pet store with YAML, and will then compile the TypeScript to a JavaScript-compatible library. And then last, we have our front end, where we have a simple HTML with a code block, and that HTML requests the main.js, and in the main.js, we get the SDK, and we configure the base URL from the mocking server, and then we use a method from the SDK to get our data and put in that code block. We can run each development command separately, but I automated it a little bit. And with the help of Lerna, I can run the npm run dev command in the root folder. And as we can see from that command, we have our Vite server is running for our front end. Our Prism server is running. The SDK has been generated. So if we go visit our front end now, voila, we see that the code block is filled with mocking data. And if we inspect the network tab, we see that with HR requests, we can see that our pets is fetched from localhost 410/pets. So the SDK mapped its method to an API request. The mocking server tries to create a data that is described by the OpenAPI document and sends it back. And this example is a fast way of starting up a front-end project that relies on a REST API for its data. So what did we learn today? Well, first of all, we learned that the Open API specification is a contract between services. It's a unified way of describing a RESTful API. There are two major approaches how to work with Open API in your project. First approach is going code first. This is where your provider provides you with an Open API document generated from their source code. Second approach is the design first approach, where you take the Open API documents as the single source of truth and let all stakeholders, consumers and providers contribute to the design of the API. We learned about tools. Because the Open API specification is a specification like HTML and JavaScript and so on, we can build tooling upon it. Tooling like document generation, like SDK generation for our consumers and for our providers as well. We can start up mocking servers that create fully fledged APIs with fake data, all from that one Open API document. And if we let automation do all the heavy lifting for us, we can majorly improve our workflow with RESTful APIs. The results are, because the Open API document in our project is the single source of truth, every team member, every application in our project, every service in our project will be on the same frequency regarding communication. Because of the tooling available to us, we can enhance our day-to-day workflow and deliver projects better and faster. And thanks to tools like automated mocking servers, we can increase independence from one another. Thank you for listening. I hope you enjoyed it. I hope you will integrate OpenAPI in your next RESTful API project from now on. If you have any questions, please put them in the chat. Contact me on Twitter. It's at MRTNVH. If you like what you see and are interested in working with me, well, we have some few job openings open at isaac.nl. Go check them out if you like. That's it for my part. Hope you enjoy the rest of the talks. Thank you for Tech Fair Live for having me, and I'll catch you on the flip side. Bye.